the third part of the explanation of the changes in NGL, and we're going to start talking about the material class now. So this next line of code here creates an instance of an NGL material, and in this case I'm using one of the built-in ones called gold. Now, as you can see, the line above is setting the active shader to be Fong, and this is where things really do change from the old version of NGL. In the old version of NGL, the shaders used to access GL material, and we can look at that by just looking at some of the old NGL demos, which use the OpenGL version of the shaders from GLSL 2.0 and belong. And what we can see here is that the shaders have this GL front material parameter, and each one of those is basically a structure where we've got ambient, diffuse, specular as part of a structure. And what we would do is make a call to the GL material function, and that would pass in the parameters that could then be read to the shader. This has now been deprecated, so there is no more calls to GL material, and what we have to do is manage this ourselves. And in the case of this example, what I've done is basically replicated what used to be in the fixed functionality OpenGL pipeline. So the NGL material class itself still stores the parameters that we need for doing all of our basic materials, and if we look in material.h here, we can see that basically what we've got is all the values for our predefined materials here, and if we look at the parameters here, what we've got is a series of NGL colors to store ambient, diffuse, specular, emissive, and specular opponent, and surface roughness, exactly the same as OpenGL has. The only major difference now is that these aren't passed to our vertex and fragment shaders via the GL material structure. We have to build it ourselves. So we can see here there is a structure declared in my fragment shader called materials, and it's got a vec4 for ambient, diffuse and specular, and it's got a float for shininess, which is basically the specular exponent. We will create a power of this to do our material. And in this case, because I'm only using one material in all of my calculations, I've got a material structure which I've called material, and this has to be loaded to the shader, and as it's a uniform, basically we set it once and this will be active all the way through all the shaders. In this case I've only got one object. If we had multiple materials, every time we change the material we'd have to load this to the shader to be the currently active uniform that's being used. And then you can see in our basic dot product calculations that are going on here that I can access material.diffuse, material.ambient, and material.specular, and material.shininess here in the shader when I'm doing my basic blend Fong calculations. So to load this into our shader, what we have to do is ensure that our shader is the currently active shader. I've created an instance of my shader, and then we make a call to this new method in NGL5 called load to shader, where the string that's passed in is the uniform that we're looking to set. So if we'll see in our shader here, we have a uniform called material, so that is the one that's going to be set in our shader, and we're setting that there. If we actually look at what the material class itself does, most of it's unchanged from the previous version of NGL. It's just that here we grab an instance of the shader library and we make a call to shader, set shader parameter 4f, uniform name, plus hard-coded .ambient. Obviously we're setting an element of the structure. So the uniform name that's passed in is material. We're then looking for material.ambient, and then we're setting basically the RGBA components to that. Then the same for diffuse, specular, and shininess. And that sets those parameters in the material. Every time the shader looks up those values, they'll be the values that we set. So this is a major departure on how the NGL 4.0 library worked, because that used the OpenGL built-ins from the GLSL shading language. These no longer exist in OpenGL 3.2 core profile and above. So once that's there, these are persistent throughout the use of that material. In this case, as I said, I'm not changing the materials, so that will be active all the way through.